All right, I put you all in the. You're all across my screen at this point. So, we're the Brady Bunch view. Yeah, you gotta look up, look down. Who's to your left? Yeah.
It's the
Hey.
story.
All right. In theory, we should be live. Hey, everybody. Welcome to the lurching, struggling virtual star party. The first time we've been able to make this happen in like 5 weeks. I don't even remember the last
Oh,
time.
longer than that.
Yeah,
It's
it's
been a
been.
while.
Well,
It
we
was still
did
summer.
one after summertime, and so, but then we weren't able to get any others because the West Coast caught on fire, and then also weather. So, but we're back, and but are we? So we'll find out. We're having some technical challenges tonight, but before we get into the astronomy, I want to introduce the three astronomers who have kindly joined me on Halloween. Again, full moon, Halloween. The show must go on. Up in the upper left, we got Stuart Foreman. Hey, Stuart.
Hi, how are you?
Good,
Good to
good.
see you.
And we got the lower left, we got Linda Thomas Fowler. Hey, Linda.
Hey, everybody. Hey.
And bottom right, we've got Molly Wakeling. Hey, Molly.
Hello. I'm dressed as Miss Frizzle tonight for Halloween.
That is awesome. Best science kids show ever.
That's how I got into this.
Yeah. So, Stuart, tell us about your conditions. What have you got going on tonight?
Well, my conditions are I'm having a lot of mount trouble, and I just lost my sequence scripting, and my guiding isn't working, and but other than that, I'm great.
So in other words, even though you are outside,
I am outside
Yep.
with a telescope
With-
and a computer,
with clear skies,
with clear skies.
yeah, you just might not be able to make the sky stuff go into the
Right.
telescope thing.
Right, so I'm working on it. So I'll be sitting here, and since we're online, I will avoid my usual string of 4-letter words, and I will be nice.
Yeah.
And I'll do my best to at least get 1 or 2 images if I can get it figured out here.
Yeah, don't worry about it. There's no pressure. It's not like anybody's watching.
It's not like there's hundreds
fine.
of
It'll be
people
fine.
watching.
Yeah, it'll be fine. Linda, how about how's your setup going?
It's going well here. I'm in Northern Virginia, but the telescope is out in West Virginia where the sky is clear except for that bright orb in the sky.
Yeah,
And things seem to be working.
yeah. People think I'm a monster for wanting to push the moon into the sun, but I'm not. I'm not. It's you'll all see. You'll all understand. Good. Well, so you've got a nice rock solid, just set up. Everything's good to go. Clear skies. Telescope is behaving.
Yeah, at least until about midnight here, and then it's supposed to get a little more cloudy, but for the star party, we should be okay.
Okay, great. And Molly, what do you got going on?
So my skies are clear, and my mount is mostly working. The go-to is a little off for some reason. I'm going to resync it here in just a second. But my remote computer that's outside in the backyard is having fits with the internet connection. So my remote desktop is being extremely slow / just failing outright. So I just rebooted. We'll see what happens.
Yeah, so
Astrophotography is hard, people.
That's what. So what? Yeah, exactly. Like you saw, I mean, it's funny. We used to do these back in like 2012, 2013, and then we shut it down because it just was so hard. It was just so hard to make this go, to get gear and clear skies line up. But when it works, it's magic, and then the rest of the time it's just struggle. So just hang out with us for an hour. We'll talk about astronomy and maybe try to show you a few pictures of the night sky or not. I make no guarantees. All
I
right.
can guarantee we get at least 2.
2. You guarantee 2 pictures. All right. I'm going to hold you to that then, Linda. All right. Well, I'm going to. So who's got their first picture to share?
I'm still coming back up. So
Okay.
Linda.
Yeah, it's all Linda. Linda,
Sure thing.
yeah.
Let me switch over here to that.
All right. And then I will shift to this. Okay.
So what we have here is the North America Nebula. There's Florida down here. Here's the East Coast. Can you see my mouse, Fraser?
Yep.
Okay. And then, here's the Canada's up here, and the US is down here, and you can kind of see Mexico trailing off the frame there. So this is in the constellation of Cygnus, one of the biggest nebula in the sky. It's this telescope is a small 80 millimeter refractor. The field of view is something like 3 or 4 degrees by 2 degrees, and this whole nebula won't fit inside.
Yeah.
And this,
yeah, it's a gigantic. So I'm just going to show people on Stellarium here what we're talking about here. So you've got the summer triangle, and you've got Deneb, and in Deneb is is a whole bunch of sort of near Deneb, which is part of the summer triangle. You've got this huge star forming structure, which is the North American Nebula, and so we sort of match the Stellarium version of what it looks like. You can see it's actually upside down compared to what Linda's view is. You just sort of rotate it around. And so what's the length of time on this exposure?
this was a 60-second hydrogen alpha exposure.
60 seconds. And that's pretty quick. I mean, did you want to try doing probably like a longer exposure with hydrogen alpha?
I can.
But if you've got another object already queued up and moving towards.
Oh, I have another object right here.
That's Pac-Man Nebula.
Pac-Man.
That's great. And you just took this one as well.
Yeah, this is, so the first image you saw was from my little 80 millimeter refractor, which is riding on top of this 305 millimeter astrophysics Riccardi-Honders telescope.
Wow.
And so, yeah, it makes my telescope look like a toy.
That's a beautiful shot. That's amazing.
And this is 5 minutes hydrogen alpha on this one.
I have to apologize if people can hear the banging going on. It's because it's Halloween. That's the night that everybody runs their fireworks here in Canada. So, and at my neighbor is banging fireworks. So anyway, please continue. Well,
So
it sounds like I'm in a war zone.
This object, I don't even remember where this object is. Somewhere in the northern part of the sky.
It's actually it's really easy to find. So I'm just going to bring up Stellarium here. So if anybody knows where Cassiopeia is, right underneath the W of Cassiopeia is the Pac-Man Nebula. So it's actually a very easy nebula to find if you're doing astrophotography. But it's such a faint object you can't see it with a telescope. But the joke that I always make is like, what was it called before Pac-Man? Like, did astrophotography, like, did very faint astrophotography rise at the same time that Pac-Man did?
I had never heard of this object growing up. It wasn't until astrophotography became a more common thing that I had even heard of it. And it's one of the few objects that looks like its namesake.
Oh yeah.
You can just hear the little thing going waka 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 across the sky.
Yeah. So, I mean, was the video game Pac-Man based on the Pac-Man Nebula?
Yeah.
I don't think so.
I vote yes.
I don't think that's I don't think that's true. But it's funny how there's this. Oh, there's another one as well. I forget what it is. There's another modernish object. Same situation.
Trying to remember.
Do we have a request for a target? I can go try and.
Yeah, I
start
can give you
another
some.
image.
I can give you some requests. Let's do some quick stuff. Can you get like a globular cluster, like at M13?
Let's see.
I almost have Saturn. I'm still just trying to get it
Oh,
focused. I think
I'm
I might
excited.
actually run outside because it's faster if I can just sit out there and do it.
And
So.
I think I figured out my problem,
Oh,
but I'm
good.
still working on it. I have to reset all kinds of calibration here, but we'll see if I can get it done.
I'm slowing there now.
So to all my friends who are watching, I warned you that this might happen.
So we know it's not a rig demo.
No.
Yeah.
And this is
So
this is
what
no shade on
software
my
are you
awesome-
using, Linda? If people want to
This
know.
is Voyager, Starkeeper Voyager, which is the software that the person whose telescope this is using, and it's quite capable. I'm still learning it, but let me. What are we doing? M13. Let me try
Yeah, if you can.
illuminance frame
It
with
should be
the,
a quick. It should be like a quick shot, right? I'm just picking some stuff that isn't like a long exposure. Then we could do like maybe the Ring Nebula.
Yeah, I can swing there next.
Yeah.
So right now we're doing a 60-second luminance exposure. So this is a broadband exposure capturing pretty much the entire visible spectrum.
Right. Z-Trex, what is this? We are broadcasting a live view of the night sky from 3 different telescopes around North America. Okay, there we go. That looks like a star, Stuart.
Yeah, this
Not a smear.
instead of showing my face, I thought I'd show guiding calibration stuff. This is the stuff that astrophotographers have to stare at, and anytime anybody thinks that this is a cool hobby, you just look at stuff like this and you want to just bang your head against.
Well, so let's talk a little bit about this. So, what is a guiding scope for?
Right. So when you do astrophotography, the images are generally 5, 10, 15, 20 minutes long sometimes, where you have to take separate images, and each image is a long period of time. And the mounts will follow the stars as the Earth rotates, but it's not perfect. So you need to have a separate camera, unless you have a fancy mount like Linda's, a separate camera to lock onto a star and to tell your mount this is where you need to stick.
Mm-hmm.
But you have to calibrate that, and that's exactly what I'm doing right now. Is I'm calibrating my mount.
And so so essentially your telescope setup, you've got 2 telescopes on your telescope. One is the one that you're taking the pictures with, and a little tiny telescope that's latched on like a remora that is there to just look at one star and tell the bigger telescope, oh, you're a little out of alignment, and to keep the bigger telescope in its alignment.
Right. And so what we're looking at right now, see the little square, and that little square is locked on that little star. And so that's telling the mount, this is every time you send a pulse to the mount, you move this amount, and this will tell it which way is north, south, east, and west.
Yeah, that's really cool. All right, Molly's got Saturn, so let's go to that.
Yeah, a really bad Saturn. But
that's a pretty murky Saturn.
It's behind a tree branch, which is why it looks so terrible. And I'm trying to get the white balance to cooperate here.
Saturn's feeling a little shy.
Yeah. My white balance is doing really terribly.
M13 was too low, Fraser.
Oh, was it? Okay, all right.
Yeah.
Let me see.
But I'm going to N57 right now.
Okay.
So here's a really terrible view of Saturn, and I'm going to go find something else here in a second.
If people ask us for Saturn, we brought Saturn.
I'm sorry, it was so good last time, but now it's getting behind my tree this time of the year. So.
But yeah, Andromeda should be pretty good for you as well.
Yeah, Andromeda looks gorgeous through this telescope. I'll go there next.
Yeah, that'd be
unless
amazing.
Stuart gets there first.
No.
Jamie Orlando asks, "Yeah, I made it. Are you taking requests?" Yeah, definitely. If it's something you want to see, let me guess. People want to see Mars, of course.
Yeah, I don't think I have it yet, but I'll go see.
Is that too close to the moon?
No, it's behind my neighbor's garage.
No, I'm sorry. I was talking to myself.
Oh,
Okay.
I shouldn't do that on a live mic.
a sadder Saturn. Yeah, sad turn.
Yeah, it is a pretty sad turn.
Sad turn. And Jupiter's up.
It's like, if I didn't have that tree there, I could get it, but it's even further behind the tree because it's further west than Saturn. So I'm sorry, folks.
Speaking of Saturn, Jamie's asking for the Saturn Nebula.
Oh yeah. I can need to go grab my phone. See where it's at right now.
It's a little higher than Saturn, so it should be okay.
Possibly. The tree kind of curves, so I might be able to. Let me check. I have a panorama of my backyard loaded into Sky Safari so that I can know whether stuff is clear of all my obstructions.
Yeah.
Might be some clouds over in the western part of the sky.
All
So
right,
let's.
Saturn, Nebula.
And so, Stuart, so you're still
No, I
using
can't.
the
I can't
guiding.
get that either. It's too far.
Yeah,
away.
I'm just sitting there. It's actually not very interesting. I can stop that for now. I'm sorry.
Well, Linda's got. I don't know what it is.
Yeah, that's where
Is that where
M57
Andromeda
is
is?
supposed. That's where M57 is supposed to be.
Oh, have you got cloud or have you got like a wall?
I think that's a cloud.
Yeah. That's funny.
So let me try M31.
So there you go. You thought it was good, and actually, it's not good.
Hey, I think I have Mars. I have to get it centered and focused and stuff, but I think it's clear of my garage, so we'll have that momentarily.
Right on. And hopefully, we should have the lander's telescope back next week. So depending on who's able to show up next week, I should be able to stream as well.
Great.
And their OPT is setting up another scope in Texas.
Oh, nice.
Yeah.
What kind?
Don't know. The same kind.
The one that looks in the sky.
The one that looks in the sky. I don't know the technical details. I don't know the technical details of this.
So there's 6 seconds on Andromeda.
What?
Very
That's
nice.
6 seconds.
6 seconds. I can get you a little bit longer.
Yeah, I mean it'll start to blow out the center. 6.
Yeah.
Maybe
Let
no.
me-
Don't go to 60. No, that'll be crazy. Maybe
right.
20.
You
That's
got
a
it.
fast scope.
Yeah, it's
Wow.
f3.8.
Yeah.
And it's got a CCD camera on it that's got relatively high read noise. So
Yeah.
even with that, it's super fast.
Yeah. Johnny Chase asks if there is a show next week. Yeah, there'll be a show next week. I'm Canadian. No problem.
We can hope, right?
Yeah, there's nothing going on in Canada next week.
No, I should have my problems fixed by next week. I just.
Well, if the country explodes next week, hopefully not too much of the matter rains down into Canada.
Yeah, we'll be fine. We've already closed the border to you anyway. All right, so
So here's 20 seconds.
I know, shots fired. Okay, so for
It's
people who
we deserve it.
We saw where the Pac-Man Nebula was over here under Cassiopeia, and then if you go further down, you can see the Andromeda galaxy. And as we zoom in, you can see, and Andromeda is the most distant object you can see with the unaided eye. And so here is
Sky's dark enough.
if you're, yeah, 2.5
I've
million
seen
light years away.
when I get to when I get to a dark sky site, I've been able to see M51 before, which is 23 million light years away at a dark sky site. Naked eye.
Unaided? That's tiny.
Yeah, I could. It was a little splotch, but I could see it. It was awesome. This was in West Virginia, and yeah,
Oh, you
that
got
was
better
really
eyesight
cool.
than I do, but than most people do. So
Well,
I was
apparently
shocked.
you can
I was really
see.
shocked to see it. I went and double checked my phone to make sure that there wasn't something brighter that I was seeing there. Nope, it was right off the end of the handle of the Big Dipper. It was no mistaking it.
Oh
It was
wow,
crazy.
that's impressive. Yeah, I mean, I've
It's very
seen
dark in
you can
West
see
Virginia.
M33 in Triangulum with the unaided
Yeah.
eye as well, but I didn't know that you could see.
I didn't know you could see M51 either. Like I was
No.
Yeah.
kept double checking my phone to make sure that it
Yeah.
was what I thought it was.
yeah, I think
I'm almost ready with Mars. Almost.
Oh, that's
I'm
incredible.
tweaking
Okay.
some settings.
so. Here's the 20-second
So my computer's
exposure,
being
Fraser.
extremely slow.
So that's the
can see-
20-second view.
Yeah, you can see some of the dust lanes there.
Yeah.
Well, that's fantastic.
Yeah, that's amazing. 20 seconds
then
is
there's-
great. Maybe,
Yeah, and the thing about this object is, as I still do battle, is that a lot of beginning photographers try to take a picture of this because it's so bright, but it's actually a very difficult thing to take a good image of because it's so
Yeah.
bright.
Yeah.
Yeah, it's got a lot of dynamic range.
It's got a lot of dynamic range, and so to really take a picture of it, you need to take short exposures of it to get the core, and then long exposures to get the arms, and then blend them.
Yeah.
Same thing with Orion Nebula; it's super hard.
Yeah.
to take.
Yeah. So
No.
yeah, I wouldn't have like recommend a longer exposure than this because it just gets so bright in the middle that you just can't, like, it just becomes harder and harder to see. But this is sort of like that perfect balance where you can see the nice little satellite galaxy down below, the other satellite galaxy up above, or is that, no, that's a star.
No, I think
No,
that's
it's M32.
M32.
Yeah, sorry, yeah,
and
the
that's
one above and then
M110
the
there.
one below. Yeah, M110
Yeah.
and then M32 and then M31 is the big one.
And this thing is huge. It's the width of 6 full moons across.
Yeah, yeah. And then and so if you went longer, yeah, you would get there's that central core would just get brighter and brighter and brighter. So
Yeah.
do you want to try Triangulum M33?
Sure.
Oh, M33. It's 48 degrees up for West Coast. Yeah, it should be okay. It's just a little below Andromeda. Yeah.
Yeah, it should be fine. It'll take it a little bit longer. It's got to do a peer flip.
I'm almost there. My computer is just going really slow, so I'm just waiting for the image to clear up now that I've switched to quality mode instead of speed mode. So.
And so were you able to get Mars?
Yeah, it's there. It's coming. I've switched the remote computer to show high quality instead of high speed, and it's taking a really long time to show me the image of the screen.
Yeah.
When I switched, so.
Yeah.
It's frustrating. It's not usually this bad. I blame everybody being at home watching Halloween movies, taking all my bandwidth. Well, I can go ahead and show what I mean, it's not really in like it's kind of blurry right now because the computer view is weird, but give me just 1 second. I can show it here. Let me change the target name. Okay. So it will look better in a minute once my computer catches up. Again, because my internet's being really awful. But yeah, there's Mars.
Oh, there's M33.
I can try and get longer on that if you'd like.
What? Oh, thanks. Now apparently I can spotlight multiple people. I don't want to. What? How do I stop this? Remove all pins. Okay. Huh. Full screen. Okay. Let's see. All right, so I'll remove that pin. So I would go for maybe a longer shot on the M33.
I can do that.
Yeah. All right, there you go, Mars. All right, we're on your Mars, Molly.
Yeah, so it's a little, my internet connection is a little bit terrible right now, so it's not very clear, but there's the red planet in all of its red glory. Earlier this evening, well, just a bit ago when I was getting it all focused and stuff, I could see some of the terrain features until my internet connection got really bad again.
I think I see some canals.
You can, yeah, I
You can
some
just
canals,
see the
yeah.
canals.
Yeah, I definitely think I see canals, and I think I see some alien spaceships, you know.
Yeah.
What about that face?
The other thing about planetary,
Perseverance, the Perseverance, the new Mars rover that's headed to Mars right now from NASA is halfway there as of, I think, day before yesterday. So I don't remember the exact like when it's supposed to touch down, but in the next couple of months, I think. Then we'll have Curiosity will have a buddy on Mars with it to do more exploration, and the new rover, I believe, is prepped to look for like signatures of life at a deeper level in the soil than Curiosity was set up for. So yeah, we'll see what we can find.
Ztrex is asking, is that the picture of the telescope that you're using, Molly?
Yes, the picture there is the telescope that I'm using. So that is a Celestron 8-inch Schmidt-Cassegrain on a Paramount Mighty mount. And I have a ZWO 294 MC Pro, which is their color camera on the back there. I do have a focal reducer on there because I have this thing configured for doing deep sky imaging at the moment, but I'm just zooming in extra much to get the planets with the focal reducer still on there. But yeah, that's one of 3 of my backyard rigs.
and normally when you do planets, you don't put a focal reducer on. Is that correct?
That's right. Yeah. So if I was dedicating, like doing some planetary imaging, I would take off the focal reducer and actually put on a Barlow to get more magnification. And I got some images a few weeks ago in that configuration that came out quite nice. But the focal reducer is helpful for the deep sky targets because they're very dim, and the focal reducer speeds up the telescope effectively. If you've used a DSLR camera and you've seen the difference between like f3.5 and f8, it's a very similar thing where the more the lower that f number, the more light you're concentrating onto the chip at once, onto your camera chip. So the image is brighter and the field of view is a little bigger as well as a result. So there's less magnification, but that's generally what you want for most deep sky objects because they tend to be quite large on the sky.
Right.
Yeah.
Here we have the 60-second M33.
So try to remove that. There we go.
So you can see the spiral arms there. And this is unlike Andromeda, which is kind of at an angle to us. This one's almost face on.
Mm-hmm. Yeah. Yeah, M33 is a great galaxy. You can really see all the structure. One of the cool things about M33 is that astronomers think that it doesn't have a supermassive black hole at the heart, the way pretty much every other galaxy that we know of does. And it's thought that it went through some kind of merger or collision that kicked out its supermassive black hole into space.
Oh, is that what the theory is? Okay.
Yeah, so it seems like even when you have 2 black holes, supermassive black holes merge, one can bounce out and be completely kicked out of the galaxy.
So one kind of makes a quick pass around the other
yeah,
one and
or
slingshot it out.
And so you can kind of get it like almost like a, I don't know, like a bolo, sort of wobbling itself out. It can impart a kick, velocity kick. And so even after the merge, it can kick itself out of the galaxy, and that's what's believed happened in M33, one of the few
Interesting.
galaxies ever seen without a supermassive black hole.
Similar thing happens with some stars, and some planets actually too. Some exoplanets. There's some exoplanets that are shooting through space without a host star, and there's some stars that are moving through the galaxy really, really fast on a trajectory out of the galaxy.
Yeah, this summer there was an article about a star that was on its way out of the galaxy at high speed.
Oh, cool.
Fraser, can you see my screen?
Oh yeah.
Okay, I finally got something working. It's gonna be hit and miss here.
Pickering's triangle.
Yeah, this is Pickering's triangle.
Yeah.
And this is a 2-minute exposure with hydrogen alpha, and this is a part of a big complex in the western it's called the big part of the Veil complex, and there's the Eastern Veil, the Western Veil, Pickering's triangle, and there's other stuff in it too, and it's huge.
Yeah.
My scope has a much smaller field of view and hard magnification than Linda's. She would be able to get a lot more of this than I would. But this is a rather pretty area, especially when it's in color.
Yeah. So for people who don't know, the Veil Nebula is
Supernova remnant.
Yeah. So it's actually it's a huge object. It's the remnant of a supernova that exploded thousands of years ago, and it's like, I mean, it really looks like that, the one you see in science fiction and stuff, when the Death Star explodes, you get this ring of material that's expanding outward. It's just this huge expanding ring that's just slowly fading away bit by bit by bit. And so which region did you say you've got?
Sorry, this is the it's called the Pickering's triangle, and it's just an area in between the Western and Eastern Veil. I'm going to get the Western Veil in a second.
Okay,
Yeah.
Great.
It's a little closer to the western side than the eastern side.
Yeah.
So I have this all scripted out, but because everything got messed up, I have to do this all kind of manually here, so it'll be slower.
Yeah. Well, it's kind of good so people can actually see the software that you use to actually take the pictures.
Yeah.
Like, again, this is live, right? So
right.
So Luke, you're having sort of like a conversation here in the chat, and normally I would just ignore this, but the point was, as a Canadian, most of the Americans are busy with their election next week, and as a Canadian, I'm not, and so that's it. That's the joke. The joke is that the rest of the planet is not having an election next week, while a lot of the Americans are. That's it. So there's no political mention either way.
Nope.
It's just the focus of the country is on going and voting and continuing on with their government.
I'm going to run outside and swap out computers because my other computer has a better Wi-Fi card. So I'm going to see if maybe that works. I'll be right back.
So we've got
really not working.
An HA acquisition going on the Sol Nebula.
And what Nancy was saying as well, which is that we've had 7 weeks of not being able to do the star parties.
It's been 7, wow.
Yeah, and so everybody being busy, all of the astronomers being busy next week with the election, because all of our astronomers are American, except for me.
Yeah, well, I should be available next week. I don't know if I will be or not.
Yeah. So we'll see what happens. Yeah, I know. I mean, the thing is, like, we always think that we're going to have good skies. We think our gear is going to behave, and it just never does.
Yeah.
Well, in 3 weeks, I know I won't be because I'll be moving, but.
Yeah.
Did you find a dark sky site?
Yeah, we're moving to Shenandoah County and the western edge of Virginia. So it's not super dark, but it's much better than here. It's Bortle 4 versus Bortle 7.
Nice.
And, oh, that's not good. What happened there?
That's a beautiful shot, though. I really like that shot. There.
Where are we pointing?
Yeah.
I love this. I got to show your picture because this is just,
Astrophotography is hard.
yeah. Remember when astrophotography
hard.
was hard? Yeah.
I don't know. Maybe that's just too low relative to the roof.
We do have some astrophotographers around the world. We've got some people in the UK and we've got some people in Australia. The problem is doing the version in like the time that we do it on a Sunday night at say 6 o'clock, 7 o'clock means that it's daytime in Australia. And so even though we've got some incredible astronomers with daytime
Although
daytime views.
earlier this year, Shaw just soldiered on down in Malaysia.
Yeah. So there you go. We got Shaw in Malaysia.
It was 41 degrees in his little tent.
Yeah.
And he was like sweltering trying to get us shots of daytime views.
Yeah. And so he's like taking shots of Venus and stuff in daytime. So yeah.
Yeah.
I think the people that we really want to get on board are people from South America because they pretty much have the same time zones that we do, but they've got a view to the southern sky, which is a thing that we just don't have. So that would be amazing.
That would be awesome.
There you go. Ztrex is suggesting that maybe you got a shot of the Milky Way.
Okay.
Linda, which
yeah, I would be nice, but I think I got a shot of God knows what. Maybe it was the edge of the observatory.
Okay, I got Western Vale here. Can you see it?
Let's see. No. Switch to the shared content. Yes. Oh, that's the good one.
Yeah. So this is all. I can. If you flip it upside, it's upside down. But if you flip it, it looks like a witch's broom.
Yeah.
And it's called the Witch's Broom Nebula.
Yeah.
Where yeah. Go ahead.
I'm going to bring. If you can, embiggen it.
Sure.
That's the opposite.
Wait, give me a minute. Okay.
I want every single pixel rolling.
I'm trying.
I'll just show people here. So
stop yelling at me.
Yelling. So we talked about the supernova remnant again. Like the actual supernova. Like in there somewhere is the black hole or the neutron star. I don't know if they've detected it, but you can see the sort of expanding sphere around it. And so the part that Stuart's got now is just this little corner down on the bottom here.
Sorry, I got the wrong one up.
Yeah. Oh.
Yeah, I know. One sec. It just things are super slow here, as well. There it goes. There we go.
Yeah, seeing the Magellanic Clouds, etc. Like I've got all these kinds of plans. I would love to do some live shots of the International Space Station. Let's set up a camera to do some meteors. How about the auroras? And other satellites. That'd be amazing. Let's live view a Starlink launch. Let's like there's a lot of stuff that I would love to be able to do, but as you can see, like it's so hard to get telescopes and people and clear skies and stuff. It is a challenge.
If things were running. If things are running super easy for me like I had planned, I would have just been able to get an image every 2 minutes. But just because I had so many technical difficulties, I had to basically reset everything. So I'm doing everything, So in next week or week after, I'll be a lot better.
Yeah. No. Or your telescope will nope. So, don't make any promises about the future of technology. Remember, photography is hard.
It's amazing how many failure modes there are.
Yeah.
Oh, so many.
Yeah. So no, Pleiades won't come up. Well, I don't know. Do you have Pleiades up, Linda?
Let me check.
Because you're in the future.
Let me check.
Yeah.
I am. I do have Pelican up.
Not for a little while for me. Neighbor's garage.
Pleiades are up, but they're too low yet.
Okay. Yeah. So we need to wait another 2 months to really start getting some of those winter views. Pleiades and the Orion Nebula, of course.
Yeah, in about a month, I can probably get them at this time.
Yeah.
My other
what's
computer is working slightly better, slightly. So I'm gonna go hunt down a globular cluster. I think
Nice.
M15.
All right. So I'm going to shift over to Linda's.
Also, y'all got really quiet. I don't know if it's me or you.
We can hear you.
Yeah, we hear you, Molly.
Okay.
So what we have here is an upside down pelican.
That's a great shot of the Pelican, though. That's really beautiful. I like that.
That's 2 minutes of hydrogen alpha.
Yeah. So so let's talk a bit about the hydrogen alpha. So when you say that you're doing hydrogen alpha, what does that mean?
So normally the like the things we did with Andromeda and M33 was a luminance filter. It lets through all the light from blue to red. With hydrogen alpha, we're letting through just a very tiny little slice of light that happens to be the wavelength where hydrogen emits light when it's excited by ultraviolet radiation. And that's a very deep red light if you were looking at it in color. And because of that, we don't have to really worry as much about light pollution or things like that. So we get a much higher contrast view of the image. The downside is that, what we could do in 20 seconds with a broadband filter would take 3, 4, 5, 10 minutes with a narrowband filter because you're letting in so little light.
Yeah.
and different narrowband filters have different band passes. So, Molly, Linda, you probably have a 3 nanometer band pass.
I do on mine. I'm actually not sure what this telescope has on it. It's probably 3.
Yeah, mine is 5.
Yeah.
Just because when I bought the filters, I was poor.
And so how long is the exposure on that shot?
This is 120 seconds.
120 seconds. Okay. Yeah. Yeah. So just to sort of show you where this is. So back to the night sky. Again, we have the summer triangle, Vega, Altair, and Deneb in the constellation of Cygnus, the swan, right at the top. Looks like a cross, but it looks like a swan with its like wings out. And then right at the very top at Deneb, you get the Pelican Nebula. And so this is what it looks like. This is what my computer thinks it should look like. And then if we switch back over to Linda's view, so you're only seeing in Linda's view just this bottom part down here. And then you've got the North American Nebula is up above. So we'll just sort of show you here. And so if you compare and contrast this view to this, sort of like hers is rotated 90 degrees from mine. Very cool. That's a nice 120 seconds. That feels like that's the right amount of time for these. I'm sure if you spend longer, 5 minutes, multiple filters, it should be kind of amazing.
That's what I'm doing. I'm doing 120 seconds for my hydrogen alpha at 2x2 bend, and it seems fine.
Yeah, these are 2x2 bend also. And then actually, while we're here, let me go find something else and not stick around there.
Right, so I'll go back to Stuart's shot. Oh no.
Yeah, I'm getting one more. I'm getting a thing right now. So.
Okay. All right.
Yeah,
but that's an amazing. Like I really love the witch's broom. That's the best part of the supernova.
Yeah.
Yeah, that's an amazing nebula.
Let me see if I can rotate it.
And it's just a huge structure. A lot of people on their bucket list of things they're going to do is to stitch together a full shot of the supernova, and so they'll take.
I rotated it so you can
good.
see it. Yeah, it's in its proper rotation.
Right. Rocco is asking, can anybody talk about the NASA infrared telescope discovery of water on the moon.
Oh yeah.
Did you want to tackle that, Molly?
Oh,
I can if you're.
yeah. You probably a little. I've only heard about stuff. I haven't read it in depth yet. So go ahead.
Oh, so the we've known about water on the moon for quite a while. The India's Chandrayaan spacecraft had detected water on the moon with a NASA instrument. I feel like almost 10 years ago, and then been confirmed as well. But so they knew that it was in the in the permanently shadowed craters at the poles of the moon. But more recently, the signature of hydrogen had been seen in the regolith coming from other parts of the moon, and so it might be. And this was maybe about 2 years ago or so. We got an announcement from NASA that there was water on the moon, but it wasn't confirmed because there's another molecule called hydroxyl, which is an H and an O, and it's not the same thing as water, and I think it's toxic, but and it can sort of give off a very similar chemical signature to water. And so so NASA used the SOFIA instrument, which is this really exquisite infrared telescope that they fly on an airplane up in the stratosphere, and they were able to see a very strong signature of water that they're very certain about. So at this point, they're almost sure that there is large amounts of water mixed in with the regolith on the moon. Not a lot, like a cup of water in every cubic meter of regolith, but it beats trying to bring water from Earth. And so obviously just finding large amounts of water mixed in with the regolith on the moon is pretty exciting, but to find out, and so just from a scientific standpoint, it seems like the inside of the solar system, the inner solar system is a lot wetter and has more volatiles in it than anybody ever thought. But also, of course, when humans go back to the moon and try to set up a permanent base, then there's actually some of the resources that people will be required to actually live there. So it's pretty cool.
Yeah, although not necessarily easy to get.
I have
No,
I
it's
have
going
to
to be it's going to be rough to get. You're going to have to bake it, and you're going to have to condense it. You're going to have to be digging it. It's going to be a mess to try to pull that water out of the regolith.
Fraser, can you see my crescent there?
Yeah, that looks great.
Okay.
That looks terrific.
Okay.
The SOFIA telescope is super cool because you might think that having a telescope on an airplane, how could that work? It's vibrating and if you fall on an airplane, it doesn't really seem like a place where a telescope should live. But they have it on this really fancy gimbal that counteracts the vibrations and motions of the plane. And for people I know who've seen it when it's flying, it looks like it's pointing everywhere. It looks like it's moving all over the place, but it's actually really steady while the aircraft is bouncing around.
Yeah.
So it's this amazing piece of engineering that the fact that it can work. And they have it. The reason why it's on an airplane and it flies really high is that a lot of infrared light does not penetrate very well into the atmosphere. So in order to see infrared, and I think it also has an ultraviolet instrument on it as well, I would imagine.
Right, but the only way to see those wavelengths of infrared is to be with a space telescope or this airplane.
Yeah.
I'm going to shift to Linda's.
Okay, I almost have M15. I'm getting the colors corrected and the focus refined.
This looks like some kind of dark nebula.
This is the Cocoon Nebula. So yeah, it's got dark and emission and reflection all kind of rolled into one.
How long of an exposure did you do on this one?
This is 60 seconds of luminance.
That's really cool. So it looks like there just aren't stars in the sky.
Yeah.
But the reality is that it's actually a region that has just dark clouds of nebula. And then inside that region, there's new stars that are forming. But they're so new that they haven't, the radiation hasn't kicked in to blast away all of this material. And so in the future, it'll turn into something like Pleiades. But for now, the stars are cloaked in the dust as they form, it's so cool to think about that.
It's a really cool object to look at.
There's a lot of these dark nebulae. I really enjoy shots of dark nebulae. And, half of it is because my imagination is just sort of thinking about how there's just these newly forming stars. And of course, back to that idea of infrared, invisible. So this is a visible instrument that's showing off the dark nebula. But if you looked at it in infrared, you would be able to see the stars inside. And it's just different wavelengths can perceive different objects in the night sky.
And it looks like Molly's got M15.
Yeah, that's M15.
Oh, great. Let's see. Yeah. That's terrific.
So M15 is a globular cluster, and globular clusters are these clusters of stars that are extremely dense, as opposed to more open clusters like the Pleiades, where and these clusters, instead of having dozens or hundreds of stars, have thousands, tens of thousands, even a million stars in some of these, over an area that's only a few light years across. And they're just extremely densely packed, and they live in the halos of galaxies. So it's not really, they're oftentimes not in the plane of the galaxy like where most of the stars and the planets and things are, but they're up above and below in the halo of the galaxy. And these are actually extremely old objects, oftentimes billions of years old, up to 13 billion years old, like the same age as some of the oldest galaxies. And there's some thought that they may actually predate some galaxy formation. This particular one is 175 light years across, and it's about 33,000 light years away from us, which is a lot further away than most of the nebula that we can see through our telescopes and things like that. Let's see if this little info sheet I'm looking at here has the age. The mass is it's about as bright as 360,000 suns, and it's 13.2 billion years old.
That's incredible. Yeah, these are. So do we know where they come from?
Not yet. We don't, like, there's some thought that they may predate galaxies. We're not sure whether, I think there was some thought originally that they had kind of like pulled stars off of galaxies and stuff. And some of them, there's some thought that there may be black holes in some of these, but there's a lot that we don't know about them.
Yeah.
But
one idea is that they just formed in these structures. We know they're old. And the other idea is that they're actually the sort of stripped away from dwarf galaxies, that they're just the hearts of dwarf galaxies that have been dismantled, and this is all that's left. But the thing that's interesting about the globular clusters, I can't believe you guys have got me saying globular cluster. Globular clusters is that they orbit around the Milky Way in a spherical, like they don't orbit in the disk of the Milky Way. They're all over the place around the halo of the Milky Way.
I think we decided that it's actually should be globular because they're like globes.
Yeah, exactly. I know it should absolutely be globular.
Nobody says it that way though, and it's like,
but Fraser does.
Yeah, but I do. I do.
Do you say globules when you're talking about like bot globules? And
I will
like
now.
Oh, no.
So, Fraser, I have Eastern Veil here.
All
it's
right.
a bad image, but I left it up so you can see kind of what we have to deal with as astrophotographers.
Yeah.
So if we look at this, we see all these.
You got to share your screen.
Oh, I got to share my screen. Oh, so you can't see my mistake. Hang on.
No, we just see you. So.
Okay, well, I'm a mistake, but here we go.
Yeah.
Hang on. Okay, so you.
Yes.
Okay, so this is something that all of us have seen as astrophotographers, but something something knocked my mount.
Yeah.
Basically, and that's what this is. This is what a knocked mount looks like. And I might have, I'm sitting right next to it. I could have, accidentally banged the tripod leg or something. But this is, but you can still get an idea what this is supposed to look like. With it's another supernova remnant. It's part of the same complex that I've been showing all evening. It's just in the same area of the sky. And it's really pretty when it's when you have a proper image of it in color.
Yeah, you'll get that if it's wind. I mean, whenever that happens, if you're working on some kind of astrophotography, you just throw that out. That frame is gone.
Well, and that's the other thing is I see a lot of beginning astrophotographers that try to put all their images into a final image. They don't understand why it looks like, it looks terrible. And what you have to do, and I say this to everybody who does astrophotography, is you have to look at every single subframe, every single one, including, I even look at all my calibration frames, because sometimes calibration frames can screw up. And you throw out, you be brutal in throwing out data. Brutal.
Garbage in, garbage out.
Garbage in, garbage out. Exactly right.
And speaking of garbage, I've got the Iris Nebula here, but it's not a very good image of it. We might be getting too much light from the moon in this frame.
Yeah, so that's the other thing is, remember, we are battling the moon, and no one has let me push it into the sun yet. So, and
the
Venus.
Tides are important. Yada yada yada.
Yada tides. Yeah. We need the moon for life on Earth. Blah blah blah. Yeah. I mean, I don't want to explode it. I mean, that would be very dangerous.
Can we just
M45 is actually high enough.
Maybe we just hollow out the middle so that it's not as like. Actually, no. We compress it so it's the same mass but smaller.
But smaller and less bright.
Paint it,
or paint it just
black or something.
Yeah, we painted it Vanta black.
Yeah. There you
go. So Luke, no, the globular clusters orbit the Milky Way, and they are there's 3 halos as part of the Milky Way. There's the stellar halo, which has just random stars and globular clusters. And then around that is the gas halo, which is all of the hot gas that comes off all of the star forming regions of the Milky Way. And it's actually kind of shaped like, where all the stars are forming in the Milky Way causes various bubbles in this big gas halo that surrounds the Milky Way. And then there's the dark matter halo, which is even bigger. And while the Milky Way is, say, like 170, 200,000 light years across, the dark matter halo can be closing in on 1 million light years across. So it's way bigger. The Milky Way is this tiny little spot inside this gigantic halo of dark matter and gas and other stars, and then the Milky Way is right in the middle. And the same thing around Andromeda, except it's even bigger. And so, in fact, we talk about how we're not going to merge with Andromeda for another few billion years, but the reality is that actually the Milky Way and Andromeda have already started to merge. Their dark matter halos have started to come together even now, even though Andromeda is 2.5 million light years away. Whoa, it's me. Okay, so what's next? Actually, we're sort of reaching the end, so you guys all have a shot. One more picture, if anyone's got a picture.
I'm working on it.
So people are asking what your costume is.
Oh, I'm Miss Frizzle from the Magic School Bus. Or with all my planet things, I could also be Interplanet Janet, although I think she was a robot.
Forget it. I'm done.
Right on time.
I was trying to get the moon, but my sequence reset and blah 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 blah.
Yeah. All right. Well, then I'm gonna put us all back on the screen. Do you have, Linda? Do you have one last picture, or are you out too?
I could get one. I was going over to the elephant trunk.
No.
But it would take a few minutes.
Yeah. So I think we'll wrap it up here.
Okay.
And we'll snatch victory from the jaws of defeat. At this point,
be able to get on the moon here in a minute.
Yeah.
Oh, also my mount is doing weird stuff. That's okay.
That's all right.
That's
Yeah,
good.
well, Moon will be there another time.
We did it. We struggled through the hour to
My
show
mount's
that.
like alarming. I'm gonna run outside.
Oh, okay, yeah. There's your telescope not working, and then your telescope like actually
Hitting the
destroying
pier.
itself somehow.
Yeah, it's like, oh no.
Yeah, we with the telescope that I usually use every week. It's always so harrowing because I'm 3,000 kilometers away from it, and you have to look at the weather forecast, and then you open up the top of the shed, and there's been many times that the shed has not closed again, and so you can have this telescope just open to the sky. It's in the California desert, so the chances of it raining are fairly low, but it does happen. And so, or the wind picks up.
Yeah.
Yeah. And it's kind of terrifying too.
I'm kind of dealing with those same fears now because my telescope is 2.5 hours away.
Yeah.
And it's not just my equipment there.
Yeah.
So if the roof doesn't close, I'm getting in a car and driving very quickly.
Yeah. So thank you everybody for watching us tonight. I'm glad we were able to bring back the star party. Don't worry, I'm not going to make any promises of what the future holds. I promise that each week we will try our best to make a star party happen. That is as far as I'm willing to.
Well, we limped through this one okay,
yeah,
I think.
absolutely.
Yeah, we had one working system one system working well rather.
Yeah. So thanks everybody for watching. Thanks to all the mods. Thanks to Nancy for working week after week after week to bring this all together. We really appreciate your help. Molly, telescope okay?
Yeah. So I didn't have enough clearance between that mount and another one of my mounts that I thought I did.
Yeah.
When I had the dew shield on my telescope, and it had actually caught on my other telescope.
Yeah.
But everything's okay.
Yeah.
That's a different kind of crash.
Yeah.
Yeah, it was in a position that usually when the mount alarms, it's because it's so far over that like the camera is hitting the pier or something. That's not what happened. It literally ran into my other telescope.
You can move them a little farther apart.
Well, I thought that they were far enough apart. I was trying to not get it so close to my plum tree that I couldn't see the zenith. So I have a very tiny backyard, okay?
Yeah. Very, very narrow horizon. Yeah. All right. Well, thanks everybody.
Thanks,
and I will be doing another open space on Monday, so bring your space questions. And we've got another question show coming out this week, so stay tuned. All right. Thanks everyone, and we'll see all of you, I hope, next week.
Yep.
Have a good night.
Bye.